In this video, we're going to look at how to generate a line of best fit or a linear regression line from a given set of data. In this example, we're a marketing manager at a jeans company, and we wish to find the relation between the demand and the price of jeans. And they give us this data list off to the right, where P is the price and D is the demand. The first question is, does the relation defined by the set of the pairs PD represent a function? Remember, a relation is a function if there's no duplicate domains, that every x value goes to only one y value. And you can see at the 22s, I have two domain values. One goes to a 58 and one goes to a 55. And since I have a duplicate domain, I do not have a function. That does not mean it can't be modeled by a line, though. In this case, they gave you the scatter plot, but you can see that if you graph these points on the xy plane, it very clearly makes a line. Now, if it didn't give you the scatter plot, we can generate a scatter plot on our calculator. Click on Stat, which is 2 over from alpha, and then hit Enter for edit. The first thing you're going to want to do when they give you a list of data is put the data in your calculator. P is going to go into L1, and my D is going to go into L2. Make sure that the pairs are next to each other. So 19 has to be next to the 62. The 54 has to be next to the 26. You can't swap the order of the relations. Now I'm going to go back to the main screen by hitting second mode. And what I need to do is tell the calculator I want to specifically see this type of statistical plot. So I need to go into stat plot, which is over the y equals. It may be in orange, it may be in blue, depending on your calculator. You need to hit second and then y equals, and you'll see your stat plots. They're most likely off. Either way, whether it's off or on, we're going to hit enter, and then hit enter to turn it on, and then also make sure that the one with the dots, the first one, is highlighted. If you have a different one highlighted, just click your arrow over to the dots and hit enter. And now when we hit graph, we're supposed to see a stat plot. But we won't see anything because more than likely your screen is not set up to go as high as the numbers you need so you can see the plot. So we'll have to hit zoom and then scroll down to either Z-Stat or Zoom-Stat, depending on the version of your calculator. And when you hit enter, you'll see it, and you can see it makes a pretty nice looking line. Now what we want to do is find out, well, if I was going to draw a line of best fit, and how well would the dots line up against the line that I draw in? How close are the dots to the line? That's correlation. Correlation is measured from -1 to +1. Negative means that as I'm going down from left to as the line will be going down from left to right, so it'll have a negative slope. Positive correlation means that it will be heading up from left to right. Does not mean that it's good or bad. Actually, what does mean good or bad is that the closer you are to the 1. So the closer you are to 1 or -1, so the closer your absolute value of your correlation is to 1, the stronger the correlation. The closer you get to 0, that's when those dots start to spread out and not really resemble a line. Hit second mode, and we're going to find our line of best fit and our correlation. But first we have to let it know that we want to find the correlation. You'll only need to do this once. Once you trigger the correlation in the calculator, you don't need to do it each time. So this is a one-time thing so that you are told the correlation when you find the line of best fit. Hit second 0 to bring up the catalog. Then go to the X to the -1 button that's underneath math and press that, and we'll go down to the D's. Scroll down till you find diagnostic on, and you see this little caret off to the left. You want that next to diagnostic on. Hit enter twice. And we'll just say done, which doesn't seem very exciting. But now when I go into stat, over to calc, and down to line reg, which is for me number 4, When you hit enter twice, you'll get R. And my correlation is very high, negative 0.949. What does that mean? It means that as my price increases, my correlation decreases. It means I'm going to have a negative slope and that the line will fit the data very nicely. Now that isn't my slope. It means that I have a negative slope. The slope is the A value. So the equation of the line of best fit is y equals A, which is a negative 1.336, x plus B, which is 86862. What does that slope mean? Remember, it's y over x. So if I have a negative 1.336 over a 1, and this is my y value, so that's demand, over my price. Every time my demand drops, my price goes up, or if I want to read it from the bottom up, every time I raise my price $1, my demand is going to decrease by 1.336, and however it is that we're measuring demand. So as the dollar the price increases, the demand for the jeans goes down 1.336 jeans. Worded a little strangely, but that's what we're looking for. The relationship found is the equation when you create the y value. Put it the y, so y equals the negative 1.336x, which us is P, and demand is a function of price is a function of demand. There we go. And that's how you generate your line of best fit and your correlation. What's the domain of this function? Now we talked a little bit about graphing and how that these are infinite, right? You have an infinite number of solutions here that you could graph. And if you plug this in and you hit graph, you'll see that as you zoom out, your line will keep going, even though all my data is wedged right in here. So what kind of p-values can you really have, though? Mathematically, any number that you want to think of. You can plug any value into here for price. But if you're running a jeans company, you're not going to pay somebody to take the jeans for you, right? And you're not going to give them away for free. So the price of the jeans is going to be a p-value such that you're talking about p being greater than 0. The price of the jeans has to be greater than 0 in this storyline. If there was no storyline, it would just need to be a real number. But this is representative of a real-world application, and so we need that price to be greater than 0. And so when you're talking about real-world applications, you always have to think about, well, if it was my money, how would I stay in business? And that's how you generate a line of best fit, a correlation, and search for a domain. Oh, how many jeans do I need if the price were $30 a pair? Well, I could go to my table, and I could either very slowly scroll down to 30, or I can go to second table set and say, jump to the 30, please. So that when I hit second graph, I'll be at the 30. And if my price is at 30, the demand would be 46, and they want to go to the nearest whole number because you can't sell 0.78 of a jean, 47 jeans. You would just plug in that X value. And that's how you use your line of best fit.